Hi there and welcome to lab number 13 titled Measuring the Focal Length of a Biconcave Lenses. We are continuing our exploration of geometrical optics and specifically lenses. In the previous lab we learned about the biconvex lens. In this case we are learning about yet different type of a lens, so-called biconcave lens. This lens is thinner in the center compared to its edges. This lens has found many different applications. Specifically, very often is being used in lasers to collimate the beam. The lasers that use this type of lens are very often found applications in skin rejuvenation and tattoo removal. So the goal of this lab is to define the biconcave DCV lens, its major characteristics. We are also going to do a hands-on experiment in which we are going to measure the focal length of a DCV lens. And finally, as a small homework, you are going to explore how these types of lenses can fix certain issues in a human vision, as well as some other common applications of these types of lenses. We will use the following equipment in this lab: a flashlight as a light source, flashlight holder, biconcave lens, clothespins, a lens holder, a measuring tape, a protractor, and finally a pencil and a large white sheet of paper. So here we have a fully established setup for our lab number 13, where we are measuring the focal length of a biconcave lens. As you can see here, I positioned the flashlight at about 50 centimeters away from the screen. You want to make sure that your flashlight is positioned at a reasonable distance to imitate the light source that produces the parallel light rays. And we also see that the light rays that are coming out of the flashlight are moving along this axis that's been drawn on a white sheet of a paper. And here in the back, closer to the screen, we have a lens, and then we also have two clothespins that have been positioned in a vertical direction. I used a small piece of a cardboard here to stick these two clothespins so that they are positioned in a vertical direction. You want to keep them as vertical and as parallel to each other as possible, and they have to be positioned symmetrically relative to the axis drawn on a sheet of a paper. So the distance between the clothespins and the lens is about 2 centimeters. And then also the distance between the two pins is about a centimeter to 2. Again, they have to be positioned symmetrical to the axis drawn on a white sheet of paper. Now, what you can observe here is that the light produced by the flashlight is hitting this biconcave lens, and it's going to be passed through the biconcave lens. It is going to hit these two clothespins, and it's going to produce the shadow. You can see the shadow here. And those are the shadows of the two clothespins that we would want to capture on a white sheet of paper, as we are going to use them to determine the focal length of this biconcave lens. So let's make a few marked dots along these two shadows on a white sheet of a paper. We are also going to mark the position of the lens relative to the axis. Now that we marked the shadows of the two pins and the lens, we can remove the lens and pins and the flashlight and continue with the lab. Okay, so here's our white sheet of paper with a sketch. We have removed the lens and the pins and the flashlight. So the first that we are going to do is we are going to mark the position of the lens relative to the axis. So this is the position of our lens. Now we are going to establish the lines through our marked dots. And extend them beyond the lens. point where the two straight lines that we established by connecting the marked dots meet is supposed to be on the axis, and that's going to be our focal point of our biconcave lens. I have labeled that point F on our sketch, and the last thing to be done is to measure the distance between the lens and the focal point, and that's going to be our focal length. So the distance is about 1, 2, 3, 4, 5, about 5.3 centimeters. So this distance from here to there is about 5.3 centimeters. So our focal length for this lens is equal to 5.3 centimeters. And finally, as last part of this lab, please give some thoughts about where this type of biconcave lenses can be applied. They're also called DCV lenses and have a whole bunch of different applications that you may find out if you do research on the internet.